How can we solve 170 divided by 12 using a ratio table? Ratios are expressions that compare quantities. Ratio tables allow us to organize our mathematical thinking to find multiples of a number and show relationships between numbers. We can use ratio tables to divide. We can also use them later on as we work with fractions. So take a look at this ratio table. In our ratio table, we have a top row and we have a bottom row. If we think of our dividing line as though we're creating a fraction, our top row is a lot like our numerator, and our bottom row is like our denominator. If we have the fraction 1/2, 1 takes the top row as our numerator, and 2 takes the bottom row as our denominator. In this case, we have one group of 2. If we want two groups of 2, we're simply multiplying or skip counting by the number 2. 1 times 2 will give me the number 2. When I'm skip counting, I want to maintain an even relationship. So 2 times 2 gives me 4. However I multiply on top, I'm going to multiply on the bottom. In the next box, I want to multiply by 3. 1 times 3 would give me a top number, or a numerator, of 3. Whatever I do to my numerator or my top row, I want to repeat with my bottom row, always looking back to my original numbers. Again, if 1 times 3 gives me 3, 2 times 3 will give me 6. If you take a look at your bottom row, we're simply skip counting or creating multiples of 2. Our top number is telling us how many times we've multiplied in order to show us the relationship. 3 2's give me 6. If we flip our ratio table on its side, it looks an awful lot like a multiple tower. You spent some time working on multiple towers in 4th grade. Think of the ratio table as a fantastically 5th grade version of a multiple tower. We're able to use our ratio table for multiple purposes, but really, it's just a glorified way of skip counting. Taking a look back at our original example, how many groups of 2 are there in the number 12? To this point, we've simply gone along. 1 group of 2, 2 groups of 2, 3 groups of 2, 2, 4, 6. Our question, though, is asking how many groups of 2 are there in the number 12? 12 divided by 2. Well, if I were to skip count by 2, attempting to reach the number 12, I know that multiplying 2 times 6 gives me 12, and multiplying 1 by 6 gives me 6. There are 6 groups of 2 in the number 12. What this shows us is that we do not need to go consecutively along our numbers in order for us to reach an answer. For example, I could have continued 1 times 4 and gotten 4/8, or 4 on our top row and 8 in the bottom row. However, if it makes sense for us to skip ahead and use a number like 6 in order to find our answer, that is entirely fine. If we return back to our original division problem, 170 divided by 12, it's important for us to define the numbers within our number sentence. For example, 170 is our dividend. It's the number that we're going to be breaking apart. We're breaking our number apart into groups of 12, which is our divisor. How many groups of 12 are we going to need? It's important for us to understand these words as we're working through division problems with any strategy. In this case, our 12, or our divisor, becomes our bottom number, much like our denominator. We start with one group of 12. We multiply by 2. 1 times 2 gives me 2. 12 times 2 gives me 24. Continuing on, 1 times 3 gives me 3. And 12 times 3, balancing our numbers, gives me 36. I can look at my numbers right away and see that going along in numerical order 1, 2, 3, 4 may not be the most efficient way for me to get to the number 170. Having multiplied 12 by 3, I'm not even halfway to 170 just yet. I may need to think a little bit larger. I know that mentally I can multiply 1 by 5. 1 times 5 gives me 5. 12 times 5 gives me 60. While I'm getting a little bit warmer, I'm still not quite there yet. In this case, I may decide to jump straight to the number 10. 1 times 10 gives me 10. 12 times 10 gives me 120. We're definitely a little bit closer now. At this point, it's important for us to take a look at the numbers that we have within our ratio table. We could continue on until we are as close as possible to 170 without going over, but sometimes we can use what we have within our table and combine our numbers, or our divisors, our numbers at the bottom that we've skip counted, our multiples, in order to reach 170. For example, we know that 120 is getting much closer. If I combine 120 and 60 using addition, 120 plus 60 will give me 180. Think about it. Too much? Too little? 180 is more than 170, so I need to take a step back. Well, I know 120 is definitely going to be helpful. There must be something else that can get me closer without going over. Take a look. What if we decide to highlight 120 and 36? If I were to combine 120 with 36 using addition, we're going to receive an answer of 156. Definitely closer. It's important for us to track our work. So, over here on the side, again, 120 plus 36 is 156. Still not quite there yet, but definitely closer. Is there another number within my table that would help me reach 70 or 170 exactly? Taking a look at my numbers, 24 would definitely lead us above. It would also take us to 180. What happens if I highlight the number 12? 156 plus 12 gives us a sum of 168. Can I add another 12 onto 168 without going over? It doesn't look that way. Let's check ourselves. We come back to our ratio table. We've highlighted 120, so we have 10, 36, which is 3, and 12, which is one group. 10, 3, and 1 means that we have 14 groups of 12. We know that 1 times 14 gives us 14. 12 times 14 gives us a product of 168. If we were to add one more 12 onto 168 and combine these two numbers, we would reach a product of a sum of 180, which would be too much. Using our ratio table, we have figured out that the closest we can get to 170 using the number 12 is with 14. 14 groups of 12. We could have continued along using our numbers and reached 14 by simply inching closer. However, within our table, without going all of the way to 14, we were able to highlight some numbers that when combined give us the quotient. In order to determine our quotient, we combine the numbers in the top row of our ratio table. 1 group of 12, 3 groups of 12, 10 groups of 12. When combined, 1 plus 3 plus 10 tells us that the quotient is 14. However, we have one minor problem. 14 only gets us to 168. What do we do with the leftovers? In order for us to find the remainder of our problem, we're going to take our dividend and subtract the number that we reached in our ratio table. 170, take away 168, gives us a remainder of 2. The quotient of our problem is 14, remainder 2. While ratio tables may be new for you or a new strategy for you, they are a wonderful way for us to organize our numbers when we're working on division and other types of skills within math. Definitely give it a try, give it some practice. Don't be afraid to make mistakes, because it's through our math mistakes that we create greater understanding.